Now we are going to work on a rhombus. So all rhombi are parallelograms. So a rhombus inherits all the properties of a parallelogram. So remember, the properties of a parallelogram are that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side interior angles are supplementary, and diagonals bisect each other. Our other properties of a rhombus first come from the definition. And if you measure all of the sides of this figure, they would be the same. So it has 4 sides that are congruent. That's the definition of a rhombus. Then if you drew in your diagonals, preferably with a ruler, connecting R to O and M to H, and then you measured all of these angles where those 2 diagonals intersect each other, they would be 90 degrees. They would form right angles because those 2 lines are perpendicular. Right diagonals are perpendicular in a rhombus. And that means that the right angles are at the center. Our other property for a rhombus would come from measuring these smaller angles here, where the diagonal cuts the angle, the corner of the larger angle. And you would find that your diagonals bisect your opposite angles. So we already knew that our opposite angles were congruent. So the angle MRH would be congruent to angle HOM. And because the diagonal bisects those 2 angles, you'd have angle HRO, angle ORM, angle MOR, and angle ROH. So this angle, this angle, this angle, and this angle would all be congruent. The same thing would happen on your other set of diagonals. So you'd have another 4 angles that were congruent. Now, how many lines of symmetry does a rhombus have? So remember, it has to completely 100% match when you fold it. And it has 2 lines of symmetry, and the lines of symmetry in a rhombus are the diagonals. So now we're going to use that information. First thing, start with your center where your diagonals intersect each other, because each one of these angles is going to be 90 degrees because those lines are perpendicular to each other. Then let's use this line of symmetry, which means that that 35 degrees is also angle 1. And then we can use this line of symmetry and find out that angle 5 and angle 4 are also 35 degrees. And then we have two angles in this triangle, and we're looking for that third angle. So we can take 90 plus 35, which is 125, and subtract that from 180. Should be, say, 125 subtracted from 180. And we get 55 degrees. And that is angle 7. And then if we use our line of symmetry, it's also angle 6. And if we use our other line of symmetry, then that tells us that angle 2 and angle 3 are also 55 degrees. Next up, we're looking at sides. So first one, HO. HO is a side of this rhombus. And remember, our sides are congruent, so HO is 13 units. And OM is 13 units. And RM is 13 units because those are all sides of this rhombus. We know OB is 12 units because our diagonals cut each other in half. Now we need to look for HB. So we know two sides of this triangle. We know one side is 13, one side is 12. We're looking for that last side. Now, this is a right triangle, so we can use Pythagorean theorem to help us figure out what that side length is. And remember that 13 is your hypotenuse, so it is C. So we have x squared plus 144 equaling 169. Subtracting that 144 from both sides. And x squared equals 25. Taking the square root of both sides, and x equals 5. So that's the length of HB, which means that BM is also 5. And 5 plus 5 is 10 units.